Okay, here we go. Dot product given U is equal to A1, B1, and V is equal to A2, B2, then U times V is equal to A1, A2 plus B1, B2. So this is how we multiply vectors. Whitney looking for a pencil again. I swear you owe me 40 of them. Yeah, that's probably mine too that you have there. Chances are it's mine. That's how we multiply. We multiply the two A values. We add it to the two B values multiplied. Any questions on that? That look pretty straightforward. Here's another one. If you want to see a proof of this, you can check your book. U times V is equal to the magnitude of U times magnitude of V times cosine of theta, which is the same thing as cosine of theta equals U times V over magnitude of U times the magnitude of V. This is really all we're going to learn today. We're not going to spend a lot of time on it. You're going to have an assignment. You can get going on it. And then tomorrow you will have a decent amount of notes to take. Tomorrow will be a long day. What? Tomorrow you get out early, right? Yep. But you do have this class. And we will be taking notes for the majority of class. So, example 1 says find the product of the vectors and the angle between them. Now, as I did this second hour, everybody got confused. They said, which two are you choosing, Mr. Gens? If you want to multiply two vectors together, the dot product says that we take the two or the two A values. So A sub 1 is -1, and A sub 2 is 2. So those are the numbers I used for the first part. They said, Mr. Gens, you should have picked a different number other than 2, because then we can't tell whether you were choosing A2 or B1, you know. Yeah, A sub 1, A sub 2. So again, this is A sub 1 right here. This is A sub 2. This is B sub 1. This is B sub 2. So you have B1 and B2. So you multiply and add them. So you got -1 times 2 is -2. Plus 2 times 3 is 6. So your answer is 4. Done and done. That's it. Any problems with that? All right, now we got to find the angle between them. You have two formulas you can choose from. Either U times V is equal to the magnitude of U times magnitude of V times cosine of theta, or cosine of theta is equal to that thing over there. So I like to use the equation on the right-hand side, and I like to say that cosine of theta is equal to, do we know what U times V is? We just figured out it's 4. Divided by, how do you figure out the magnitude of a vector? Square root of A squared plus B squared. Square root of A squared would be -1 squared plus B squared would be 2 squared times square root of 2 squared plus 3 squared. So I want to find the angle between them. So cosine of theta is equal to that. So you get cosine of theta is equal to 4 over the square root of 5 times the square root of 13 is equal to 4 over the square root of 65. So if the cosine of theta is equal to 4 over the square root of 65, how do you figure out theta? Inverse cosine. So I take out my calculator. Cosine inverse of 4 divided by second square root 65 and enter 60.26. Piece of cake upside down. Yeah? Any questions how I got that? We put all technology away that we use for communicating for purposes that are not appropriate, and we focus on our mathematics. What? Because based off of what we did a while back ago, the magnitude of u, we defined that last time, is equal to the square root of a squared plus b squared. We've said that before. Very good question, Taylor. Excellent question. So good that if I had a candy bar right now, I would give one to you. No. Nope. Nope. That would be later on, and today's the only time I'm really feeling like that. So I just want to show you guys what the heck that actually means. If you got a little graph here, and we had one vector that was what, 2, 3, and we had another one that was negative 1, 2. So if you look at these vectors right here, okay, and you want to find this angle between them, we said that that was 60.23 degrees. That's what we found, okay? If you have those two vectors, that's what we found. And we found it rather quickly, did we not? If you want to see the proof why that works, again, you should see your book. You try the second one on your own, okay? Try that next one on your own. See if you can do. Oh, everybody gets mad when they see this. Don't get mad when you see this. I minus j, that's just 1, negative 1. And 3i plus 4j is just 3, 4, okay? So there you go. So those are your vectors in component form. Go ahead and find their product and find the angle between them. Practice that. Wow, Nathan. Wow. I feel like we're regressing in our relationship. Yep. Okay, so you should come up with, what did you get for the product? Negative 1? A times B should be equal to negative 1. And then you should get the cosine of theta is equal to negative 1 over 5 square roots of 2, or the square root of 50. Did you get that? And so if you inverse cosine, theta is equal to what? 98? 98.13. Now, let's make sure we got this, okay? If we do cosine inverse of negative 1 divided by the square root of 50, 98.13. So you maybe forgot a set of parentheses in there or something? Well, 50 is 5 square roots of 2. I just did so we wouldn't mess up. So let's do cosine inverse of negative 1 divided by parentheses 5 square roots of 2. Close my parentheses. Because we're not just dividing by 5, we're dividing by 5 and the square root of 2. Oh, okay. 98.13 degrees. Hey, if you look at this, the cosine value is negative. Where is cosine negative? The first quadrant or the second quadrant? Second quadrant. Therefore, you know that your angle is in the second quadrant, which means it's an obtuse angle. It's greater than 90. And sure enough, we came up with 98.13. How do you like them apples? You like that, don't you? Okay. So any other questions about this example before we move on? All right. Orthogonal vectors are perpendicular. Given u and v are non-zero vectors, meaning that they're not simply just 0, 0, that'd be very boring, wouldn't it? Okay, so given u and v are non-zero vectors, they are perpendicular if and only if u times v is equal to 0. So if you multiply two vectors together and you get 0, you know that they're perpendicular, or they are orthogonal vectors. So IFF is shorthand for if and only if. Did you learn that in geometry? Oh boy. There's so many shorthand ways of writing stuff in mathematics. It's kind of a new language. So, raise your hand if you took the ACT this past Saturday. Okay, a few of you guys, you were almost at the pinnacle of your math knowledge to be able to answer every question. We haven't done conic sections yet, which is something that you'll need to learn how to do. But otherwise, how did it go? A+? It was easy. Wow, wait till you get a 13 back on that score. Yeah. We'll see how easy it was. Yeah, well, simple mistakes all the time, right? That's the way it works. So hopefully you guys did very well. I hope you did very well. If you don't, take it again. And, just get in the school you want. After that, it really doesn't matter. So, okay, determine whether the following vectors are orthogonal. I will simply multiply them. So I'm going to take A times B, and I get -2 plus +2, which is 0. So I would say that these are orthogonal. Two times -1 is -2, and 1 times 2 is 2. Add them together, I get 0. So then, if you look at this vector right here in component form, we have 5, -3, and you have -6, 10. Whoop. All right. And so if we multiply those together, you would get -30 plus -30, which is -60. That is not 0. Those are not orthogonal. Sad face. Eyeballs. He's cross-eyed. Hey, that's not nice. You guys all think it's a he. It's a girl. She's got red hair. There, check it out. Wow. Yeah, it does. Guys don't have red hair. Look at our class. Do you see any guys with red hair? Yes, I see girls with red hair. Yes, thank you very much. Summer. Okay, there you go. Here's your assignment. Your side. Nathan, your words, sticks and stones may break my bones, but your words, Nathan, will never hurt me. There you go. Go to work.